All right, so I was just going to review some of the questions on the worksheet that you sent me. The first one is you have a physician that orders 50% oxygen through an air entrainment nebulizer to a patient with a tidal volume of 500 milliliters and a respiratory rate of 40 breaths per minute. If the maximum nebulizer input flow is 12 liters per minute, what total flow will the patient receive, and will this meet the patient's needs? So the first thing you probably want to find out is the needs of the patient. Let me erase that and start up here. And to get that, the first thing that you want to calculate is their minute ventilation. So minute ventilation, remember, is the respiratory rate times their tidal volume. So we're going to take their respiratory rate of 40 and multiply their tidal volume of 500. And you get a minute ventilation of 20,000 milliliters. And again, that's their minute ventilation. And then you're going to take that minute ventilation, multiply it by 3. Because generally we need about 3 times our minute ventilation to meet our needs for flow. So if we take 20,000 times 3, we get 60,000 milliliters. Or more commonly, it's put in liters. So that would be 60 liters of flow. So that's the need of the patient. Now we need to see what the actual air entrainment nebulizer is doing for total flow. So that's where we would utilize our magic box. So we would use a room air of 20% up to 100%. And then in the middle, we would put our FiO2, which is at 50%, is what the physician ordered. Then you would take 100 minus 50, which is 50, and 50 minus 20, which is 30. And then you would take 50 divided by 30, and you get 1.7. So our ratio is a 1 to 1.7 ratio. So then we're going to add those two numbers together. So 1 plus 1.7 is 2.7. And then we would multiply that by the liters per minute that the nebulizer is flowing at, which is 12. So we would take 2.7 times 12, and that gives us 32 liters. Well, it says that the patient is requiring 60 liters. The nebulizer is only producing 32 liters, so we are not meeting the patient's needs. So this one would be no, we are not meeting the patient's needs at this time because our nebulizer total flow of 32 is not meeting the patient's demand, which is 60 liters per minute. So that's the first one. And then I looked at the second one here, and it says a physician orders 35% through an air entrainment nebulizer to a patient with a tidal volume of 450 milliliters and a respiratory rate that should be of 30 breaths per minute. If the maximum nebulizer input flow is 15 liters per minute, will the total flow meet the patient's needs? So again, the first thing we want to do is look at the patient needs. And we'll go ahead and calculate their minute ventilation again. So we're going to take their respiratory rate of 30 times their tidal volume of 450. And we multiply those together, you get 13,500 milliliters. And then don't forget, we need to take that 13,500 times 3, and that gives us 40,500 milliliters, or more commonly, it's going to be 40.5 liters. And then we need to calculate total flow from the nebulizer. So again, we're going to do our magic box. And the FiO2 that they are needing is 35%. So we would take 100 minus 35, and that gives us 65. And we would take 35 minus 20, which gives us 15. Then we're going to take the 65 divided by 15, and that gives us 4.3. So it's going to be a 1 to 4.3 ratio. Again, we're going to add those numbers together. 1 plus 4.3 gives us 5.3. And we're going to take that 5.3 and multiply it by our nebulizer flow of 15. And 5.3 times 15 gives us 79.5 liters. So the nebulizer is giving us a total flow of 79.5 liters. Our patient is requiring a total flow of 40.5 liters. So yes, we are meeting the patient's needs for this problem. So hopefully that answers a couple of your questions. If there's anything else that you need, just send me a text or an email, and I'll try to figure out a way to get that explanation to you. Thank you.